how many total degrees are in the interior angles of a convex pentagon? How many total degrees are in the interior angles of a convex pentagon? All right, let's take a look at this problem, see what we're going to do with it. First of all, I think the best thing to do is just draw a pentagon. It doesn't have to be regular. Now, regular, folks, means all the angles and all the sides are congruent, all right? And trust me, that's a hard construction to do. It requires a good old construction with compass and straight edge. But we're just going to go for a nice, any kind of convex pentagon. How about home plate? Why not? Let's make home plate work here. How about it? We'll draw it. There's one side. There's another. Did y'all know home plate was a pentagon? You do now, if you didn't know that originally. When you play baseball or good old softball. Let's see. Well, it's close to a home plate. There we go, a little further up. And let's bring it across, about right here. And we'll bring that up there. It's not a perfect home plate, but you get the idea. So, pentagon, there we are. Convex. Convex simply means all the angles inside, and they're all going to be between 0 and 180. Now, we could have an acute situation, possibly. It wouldn't be not very pretty. But notice these are going to be, and we could have actually pushed them out a little bit further there. So the idea is they're between 0 and 180 to make a convex situation. So the question is not what are each of these individually measured, because they could be almost anything. But what we're looking for is, what is the sum? How many total degrees do we have here? To do that, we're going to call a little trick. It's not a total trick. But you look at this thing and you say, well, Ernie, if we could break that down into a paved situation of more figures that are attached together to each other, well, let's see what happens. Let's use from one vertex here, pick it up from right here. We're going to take a diagonal, let's draw it right in there, okay? And we're going to do another one right here. Now, if you'll notice what we have done here, we've created 1, 2, 3 triangles. Now, everybody knows, I think everybody knows, well, most of you do who are getting a problem like this, know that there are 180 degrees in each problem. Now, by the way, the pentagon means 5 for penta, all right? And gon means we have 1, 2, 3, 4, 5 sides, in case some of you were wondering, well, how do you know to draw that? And then we got 5 angles. There's one, there's a bigger, a little, and one that's got 3 inside of it, 3 that are composing that big angle there. All right, so you say, well, how are we going to figure this out? We're going to notice that these 3 angles add up to 180 degrees. Remember I said there's a set total for any triangle. We also notice that this set of triangles, this old triangle, these set of angles, these 3 angles are going to add up to 180 degrees. And notice they're starting to come together. Gee, if we'd forgotten this one, we would have a quadrilateral. It gives you a little idea, two triangles there, all right? But we've got a pentagon, so we got another one, which means another 180 degrees. So basically an easy way to do this, to count them up. And again, you don't have to worry about what individually we have here, all right? All these angles, we have no idea what we've marked here. If we knew maybe 4 of the degrees, 4 big angles, we would be able to find the 5th, that kind of thing. But we not got that luxury here. So let's take it and see where it's going to go. It's going to be 180 plus 180 and plus 180. The grand total, 540 degrees. Once again, each triangle gives us 180. Now, those of you who are taking geometry this year, and some of you are taking it right now, and some of you are going to be starting it in the semester here, and different ways different folks are doing it. Some of you had it last semester and you're done with it. And you're probably going, don't bring me up to that again. But what you had was a formula that would say n minus 2, where n is the number of sides, all right? And we would take it and multiply it by 180, because basically this names how many triangles I could draw. Notice I had 5 sides, 3 triangles, n minus 2, 5 minus 2, all right? If I had gone with what I showed you a minute ago, where we had just 2 triangles and a quadrilateral, that'd be 4 sides. 4 minus 2 is 2, all right? 2 triangles. But here we got 5 minus the 2. We're going to multiply it times 180, and that will give us, guess what? 3 times 180, which is simply adding up 180 3 times, 540. So those of you who are just getting to learn a little bit about convex polygons of different sizes in the 6th, 7th, and 8th grade, this is where you're going to be able to do it. If you can draw some diagonals, man, those triangles make things pop, make things a lot easier to work through.
For more math help, visit TNLearn.org.